Good morning. So excited to see you all here. Oh my gosh, there's so many people here today, as well as Laura's class. We're so excited to see you all, and welcome, Jessy. This is the experimental weaving talk series. We like to get started right on time, and so there'll be other people joining us as we begin. The experimental weaving talk series is an opportunity for us, for Laura and I, to invite weavers that we admire to discuss their approach to weaving and experimentation. And our goal of this whole series is to bring attention to those weavers and the way in which they animate possibilities for woven structures and their own weaving practice. These talks, of course, are intended for the public, but also, just so you all know, we also are joined by Dr. Laura Devendorf's class in the Creative Technology and Design program. We're so happy to have all of you here this morning. This conversation will be recorded, so just FYI. And please put your questions right into the chat as we go. Jessy will give their presentation, and then we will have a question and answer segment at the end. So I am going to hand over the reins to my amazing colleague, Dr. Laura Devendorf.
Thank you. I knew you were going to say doctor. It's becoming a habit.
I'm sorry. I'll stop. I'll just stop. I'm honoring it. I'm honoring the work.
Thank you. Thank you. I'm going to call you exclusively Professor Stephen Frost.
That's fine. I'm okay with that.
From now on. Cool. Well, thank you, everyone. Maybe just to kind of get us warmed up for online talking, if you want to just take a moment and say hi in the chat, maybe where you're calling from or viewing from. I guess calling is something people did in the before times. Now we do video conferencing because we're in the future. Yeah, it's really good to see everyone. Well, I'm really excited today to introduce Jessy Lu, who is joining us from Taiwan, where it is 11 p.m. And so thank you so much for working with strange time zones and things like that. So Jessy came to our attention through the application process of the experimental weaving residency. And through our interviews, what I really came to admire about her practice was the way that I was trying to think of the right words for this morning, but you have this amazing ability to bring awe to the most simple things. So it's like this kind of beautiful way of combining structure and material that makes them more than the sum of their parts, right? There's this kind of emergent, like, whoa, this is kind of cool. I think earlier in this series, we've looked a lot at weavers whose like complexity in their practice is multiple layers and shape changing and things like this. And I think Jessy brings in this really beautiful current of like concept and history and meaning and message and weave structure. So I'm really excited to introduce them today and to hear their perspective on what is experimental weaving. So thank you, everyone. And with that, I will turn it over to you, Jessy.
Cool. Thank you, Laura. Thanks for those generous words. I hope I can live up to your expectations. So please feel free to give me your feedback in the comments and I'll just get started. And I'm going to assume that everything on the slides are going smoothly. If that is not the case, then feel free to unmute yourself and chime in. All right, so by way of introduction, I graduated from the Rhode Island School of Design in 2015 with a degree in textiles. I worked at Apple for 6 years in 2 different roles. The first one was as an R&D specialist in the Textiles Innovation Lab, working on prototypes for both shipping and future products. And then the second was as a materials engineer, taking one-off prototypes from the lab into various stages of production. Now I am currently on a Fulbright research grant studying decorative and functional knots in Taiwan. And this talk will cover both concepts I encountered in industry as well as concepts that I deal with in my art practice. A lot of the industry stuff is proprietary, so I won't speak to any specific examples from there, but I will speak to certain frameworks and certain sort of known released materials that exist today. And one more thing to note is one of the key takeaways that I hope that is imparted from me to you is I think that by tightening the feedback loop between industry materials and development or production and individual creators, there is this ripe space of experimental weaving that can be explored. And I hope that I cover some of those concepts. So one thing that I like to talk through is a framework for thinking about the experimental process. And so this is a graph that I took from a statistical experimentation textbook. And I think it describes this process of induction and deduction, where you deduce from what you know today and induce by collecting samples and data to further refine your current understanding. Having this process explicitly defined like this enables more intentional and focused experimentation. And I also like that it describes an ongoing and never-ending process. I think it helps us hedge against complacency with what we know today and yearn for more information. The next concept that I want to introduce, this is one that I think is a very specific methodology for doing data analysis called a design of experiment. And this is something that we do in industry. How this works is first you start by defining your relevant factors and responses, where the factors are the input variables and the response is the output and the outcome that you're trying to control. And so the example that I have here is for something like fabric thickness, and the factors might be the number of layers. If you go from a single to a double layer fabric, the fabric gets thicker. It might be yarn size. As the yarn size increases, the fabric gets thicker. And then there might be this hypothesis that you have of, as you increase the float length, the fabric becomes thicker because the yarns are packing and increasing the dimension of the fabric in the Z dimension. And so with the right statistical tools, you can actually determine which of these factors are the most dominant and also to what extent through measurable percentages. And so here is kind of that workflow. I made up this data on the left just as sort of like a hypothetical example, but this is the raw data on the left. And then on the right is sort of how you would analyze the data and visualize the results. And you can see that once the data is all plotted on these two variability charts, that the largest driver of change in the fabric thickness in this data is the layer count. And so of these three factors that we've identified, the layer count, the yarn size, and the float length, these statistical tools can tell you which are the most dominant and to what extent. And this enables you to redirect your focus on the factors that will have the most impact on your desired outcomes. And then what's more interesting about these tools is that there might be a factor that is not as obvious or as easily predicted. It's a little bit intuitive to say that as you increase the number of layers, or if you increase the thickness of the yarn, that the fabric will get thicker. But there might be something like a yarn twist, where you would imagine, like, as you twist the yarn, as you increase the twist, the yarn becomes more bound, and that decreases the effective diameter of the yarn. So it might be thinner. You might think, okay, it's going to weave a thinner textile. However, it might be that the bending stiffness of that yarn is bigger, and so it needs to travel more in the Z dimension in order to change directions. And that might actually increase the effective thickness of the textile. And so a tool like this is going to say, like, okay, with this unknown factor, how do I actually incorporate it, collect the data, measure it, and then it really refines your understanding of the mechanisms that are at play in this material. And then so the last concept that I think is important is just sort of like mapping out the space. So you have these two sort of methods of experimentation, and then you need to know, like, what knobs can I actually turn? And so there's a whole host of factors that you can control. There's on the yarn side, like bulk material, the luster, the amount of twist in the yarn, in what direction that twist is going. There's a whole panoply of parameters here. And then on the fabric side, just as many. I think everyone here is like pretty familiar with just the infinite permutations of like plain weave, satin, and twill. So there's already like so much that's not captured by this matrix. But even outside of fabric construction, you have the machine type, the way that the weft is delivered, of different types of finishing methods, whether it's cutting, lamination, insertion. So there's just so much that you can do here. And so altogether, you get a map of this space, and in this like very extensive matrix, all of these individual cells and squares are sites of potential exploration. And then so what do you do with this matrix? So if the matrix is used properly and you have full command of the space, well, you could be the chosen one. but actually, in all seriousness, there, there's some very cool things that you can do in this space. And I'm just going to speak to a couple of different landmarks in this world of textiles, in the map of the space, in the development in the industry that I think are really interesting. And I hope are things that are new and interesting to you as well. So the first thing is filament cross-section. So why is this interesting? Well, the filament is an individual strand in the bundle that composes an extruded yarn. And so the cross-section actually can be uniquely designed. And the most common cross-section that you can imagine is circular, but more complex shapes can be made. And looking one down from circular, there's trilobal. This is actually quite common in industry. And this increases the surface area of the yarns. And so the fabric can wick away moisture better. The hash is not as common, but just speculating on the function here, if you wanted to use a filament like this, it would probably behave more like a beam and you would have higher bending stiffness. And then on the right, you have this hollow cross-section. This is another quite common cross-section in industry. Since the center of the yarn can hold dead air and air is a poor thermal conductor of heat, this can be used in a fabric to create a fabric. This can be used in a fabric to create insulation. And so actually, all of these yarns too, it's interesting, they'll have different optical properties. So the trilobal yarn will be better at scattering light, and then the hollow yarn is going to be more translucent. And you might say, okay, well, this all feels really abstract. You have this like tiny filament. How big of an impact can it actually have on the textile? Well, I think a perfect example is in nature, in the polar bear. And polar bears' hairs are actually hollow, and you can see in the SEM that that is an image of a single polar bear hair. And then it's also translucent. And so because they're hollow, they have these different optical properties. It's why they appear white, but they're actually clear. And so you can see actually there's a very real utility to these principles. And in this case, it's a utility to enable survival. Okay, another example that I think is really interesting is bicomponent. So this is a material category that describes two different material types that coexist in one yarn. And a lot of different types of materials can be put together to achieve different effects. I'm going to talk about two of them. So the one on the left is a bicomponent yarn that is co-extruded side by side. And so they're connected in this way. Typically, this is done with a PET and a PTT chemistry, or both of these chemistries are within the polyester family. And the key to processing this fiber is that when you apply heat to the fiber, there is differential shrinkage with the two materials, so they shrink at different rates. And then that causes the yarn to coil. And then so that yarn can actually behave like a spring. And so this yarn becomes a really viable alternative to an elastic like spandex. And spandex is a material that actually poses a lot of problems. There are certain environmental problems, like you can't recycle it after it's being used. So it just ends up in landfill. But then also it is susceptible to degradation under certain environmental conditions, like with UV exposure, with exposure to chemicals like sunscreen and lotions, which is why your bathing suits or your bike shorts might sort of like stop becoming elastic over 1 or 2 years. And so this yarn will just better resist that. And then I think something that like is going to be important to all of the weavers here is standard elastic yarns. When you try to weave with them on the loom, if you're creating a warp and winding it on, or if you're trying to deliver it in the weft, the yarn is just super hard to control if you're trying to deliver a spandex yarn. But what the benefits of this yarn can confer is it will weave like a standard yarn, and you can apply this heat process after it's woven. And so you can arrive at a textile that is homogeneously woven, but maintains elastic properties in the X and the Y direction. On the right, I think is another great example of a bicomponent yarn. So very poetically, this is called an island in the sea yarn. And these ultra-fine microdenier filaments are the island, and the sea is this, it's a polymer, it's oftentimes like copolyester, and that can be dissolved away after weaving. And that results in a textile that feels like suede or microfiber. So I think really cool materials. One last thing that I want to note in the landscape of the world of textiles is weft delivery. So I think that with weft delivery, there are a couple of different, I mean, there are just like many different mechanisms that can shoot a weft into the shed of a textile. But a key distinction that I think is important is whether or not the edges can be closed or whether or not the edges are cut. And so a lot of very common industrial looms have cut edges, which means the weft gets shot across or pulled across, and then it's cut on both sides. And there are two different types of technologies that can actually weave a closed edge fabric, and that's a needle loom or a shuttle loom. A needle loom, I will probably not get into too much today just because it is like a very specified technology for narrow woven textiles. So narrow woven textiles are made on a specific kind of loom, and they often make webbings such as seatbelts, straps, luggage straps, watch bands, things like that. But there is, I think, this like very interesting relationship between shuttle weaving versus all these other technologies. And I think one of those examples, it arises when you are trying to weave a tube. On the left, you can see that with a cut edge technology, the tube will have seam allowance, which means there's excess material. And on the right, you can see that with a shuttle weaving technology, which delivers the yarn in sort of like the weft yarn in a spiral shape, you can actually get what is effectively a seamless tube. So then what advantages does this seamless quality confer? Well, a really explicit example, this is actually one of the examples in which shuttle weaving technology is used most prominently, aside from things like selvage denim, is in making biomedical textiles. And already the ability to weave a seamless tube with a shuttle loom is for biomedical textiles is like a huge advantage, because having this excess and non-homogeneous material at the edges can be sites of potential complication and risk. But one additional benefit to industrial shuttle weaving, besides the ability to make seamless tubes, is the possibility for discontinuous wefts. This is a tapestry technique, which basically describes a process by which the weft yarn does not pass across the whole width of the textile. It can stop halfway and turn around. And so when you're weaving a bifurcated tube, this becomes really important. There are two ways that you can bifurcate the tube. And the bifurcation is important because you're trying to like maybe embed this material inside the body. It might be like for like an arterial system or your like lung system or an aorta. But the point is the bifurcation should happen and the textile should be homogeneous across the areas that are bifurcated and not. And so you can see in the table below, one method for creating this bifurcation is by subdividing the warp. You have your seamless 2-layer tube, and then you can subdivide each of those layers into 2 layers to make a 4-layer fabric, where the top 2 and the bottom 2 are connected on the left and the right edge to create this bifurcation. But the cost to doing this is you get reduced warp density because you are using fewer warps in the bifurcated area versus in the non-bifurcated area. And so this discontinuous weft technology is something that becomes really useful because on the right, you can see another way of creating bifurcation is rather than splitting the warp, or rather than subdividing the warp, you can split the warp, and then you can make 2 smaller tubes that run side by side. And in that case, the fabric qualities in the bifurcated area and in the non-bifurcated area are the same, which is desirable in the medical application. Great, so I think that those are some landmarks in the map of the space. And in general, we have these 3 concepts that define experimentation and how that plays in the area of weaving. And now I want to talk a little bit about how that actually applies to my art practice. So my practice is very much a place for me to indulge my interest in fiber and material composition. This rope that I found at the hardware store may seem generic, but I think there are a lot of interesting ideas here. And notably on this slide, the entire composition of this rope is synthetic, wherein the braided sheath is a polyester multifilament yarn with a retroreflective tape weaving in, and then the core is also multifilament, polyester multifilament bundle. And so what I find interesting conceptually about this material is there was like a very intentional decision to dye this yarn a beige color to match the cosmetic appearance of a natural fiber, something like jute or hemp or cotton. And it's just interesting to observe in this industrially manufactured material, this imperative to draw a connection or a cognitive association between historical uses of material and how they're used today. And so what have I been making with this material? Well, as I mentioned, I've been working on this knot project, and I am primarily interested in using photography as a medium of like sort of capturing my material interest. I think that these images really capture the bicomponent nature of the braid, because the polyester yarn behaves in interactions with light in a way that is a little bit more predictable. The foreground is light and then the material recedes into shadow. But the opposite effect is true for this retroreflective yarn. And you can see that when the material is further away, it's actually lighter and illuminated. And when it's closer to the surface, it's darker. And so it kind of defies your expectations of how light and space interact. And then the photographs in the corner are also a different form of documentation where the images are taken with flash. And I think that it sort of like reveals the skeletal structure using this retroreflective tape. And it shows that there's sort of this microstructure of the yarn path within the braided cord, which itself follows a path within the larger knot construction. And so I'm really interested in these ideas of layering and scale, of zooming in and out, as well as traditional forms being made in contemporary materials. All right, and so while a braid really is, it's still a weave structure, it's just constructed on the bias instead of on the orthogonal. I will turn to experimental weaving constructed on a loom. So a plain weave textile is the simplest design that you can make on a loom, but even a plain weave can be quite complex. And so the top two images are the same fabric. The photo is just taken at different angles. And the color shifting effect is created by the 3D nature of plain weave. So even if the fabric itself looks plainer, there's all this surface topology that can be leveraged for interesting optical effects. And then I think that optical effect is described by the 3D model below. So on the far left is just a top-down view of a plain weave textile with warp and weft depicted in red and white. And so with one angle of view, you get more proportion of red and the other more proportion of white. And so this shift in color is just because the plain weave is fundamentally a 3D structure. And so what I make with these textiles are these works of art. And I think that they maintain this iridescent quality, but there's also this interplay between flat plane and perspectival space that's created through the gradients. I feel like that really sort of captures the ethos and beauty of plain weave fabrics being both 2D and 3D. And then in addition, this idea of like historical and contemporary coming together, this iridescent technique is something that is also used in traditional Thai silk, where the warp and the weft are different colors, and there's iridescence that is conferred through the like optical properties of the silk. But these materials are all using synthetic materials instead of silk, and then they also use algorithms to determine the rate of change in the color in these gradients. And both of those are, in creating these artworks, are only possible using the techniques and tools that we have access to today. Okay, getting a little bit more complex in plain weave, there is Jacquard. And this particular fabric on the left was made on the TC2 loom, and this is a single layer Jacquard. And you can see in the drawings on the right that a single layer Jacquard is defined by when the target color, in this case, the weft yarn, is weaving on the surface when it's desired to be visible, and then it moves into the back to float or maybe infrequently tuck to switch positions with a different color. It should also be noted that this is a very popular technique used to make photo blankets. And on an industrial loom, you can get an even more refined and elevated effect. This is a fantastic example because you can actually see the warp and weft colors. You can see that the warp is a traditional black and white end-to-end warp to achieve color value, lightness and darkness. And then the weft is striping with a range of different hues to blend in all of the colors to render this Thomas Kincaid painting. And then beyond what you can do with single layer, you can also do double layer with a double layer that has no connections except for the points at which the colors switch. This becomes an open pocket, which is an opportunity for insertion. And then if the layers are connected, it becomes a thicker and more robust textile. And then, of course, further divisions of the warp is possible to make more than 2 layers. You can get mind-boggling complexity through this. And I think that Catherine and Melanie's works are really wonderful examples of this. And then as far as my art practice is concerned, I am interested in Jacquard as like this method of image processing. I find it really interesting as like a physical manifestation of algorithms. And I think the piece on the right is sort of driving at that. So the top and the bottom of the work use the same image, but there is a shift in the weft yarn colors from red, yellow, and blue to green, orange, and purple. And in shifting the colors, the allocation of leaf structure, which is actually like the structural property of the fabric, that also shifts. And I think there's something really visually intriguing about that. And then in my last example of Jacquard, this is a woven piece that I made on the Visty Jacquard loom. This textile can expand and contract using this paper folding pattern. And this effect is created through the interaction of rigid panels with more mobile channels in between, which is achieved through leaf structure. So the rigid panels are created through these like shorter float lengths in the textile, as well as very frequent tie downs or anchor points. And then the opposite is true in the channels. And then in the next slide, I'm going to get to some of the mechanisms that are at play here. So one thing to note is that in the rigid panels, the material per unit area is higher. And so by increasing the frequency of the tie downs, what you're doing is just driving more material into the textile because the tie downs are forced to take a longer path. It's forced to take a more tortuous path through the construction. And that is not the case for the looser channels. And then the second is that in the more rigid construction, there's just a lot more interaction in the warp and the weft, and that's due to both the frequency of the tie downs as well as the shorter float length in the top and the bottom layer of the textile. Due to the increased yarn friction, the movement of the yarns are restricted and there's less mobility in the fabric matrix. So that's how you get these areas of rigidity as well as stress relief in these channels that have less friction and have less yarn. Okay, so taking a step back, I've covered some interesting developments, or what I think is interesting developments in industry, as well as things that are happening in my own art practice. I think that invariably the two spheres influence each other, and the feedback loop between the two can be further tightened still. I think there are a lot of interesting materials that are coming out of industry that are only viable to produce at scale. But if there's cross collaboration, those really interesting materials could be available to individuals and smaller institutions. So I think that there's a lot of value to that sort of like unidirectional like movement of materials, but I think that there is sort of this like cyclical quality too, because I think in turn, artists, craftspeople, and individual creators, academics, these are the folks that really can push boundaries of what is possible in the name of exploration for exploration's sake, as alluded to in the last talk. With no direct application as a constraint, I think a lot more new discoveries can be made. And then I think in that case, the area of experimental weaving can really be pushed forward. And that's at least what I found, having a little bit of both perspectives. So that's my major takeaway from doing this work over the last few years. But one last point that I make is we've talked a lot today about experimental weaving. And I think that there are so many technical attributes of the weaving process that are just profoundly interesting, complex, and still not very well understood. I think we're still very much at the foothills of what is possible with weaving. But that being said, I think that weaving is one craft discipline out of many, and I am also an advocate of knitting. And I think knitting is a fundamentally different technology, and the parameters that influence knitted fabrics are equally as abundant. And so perhaps in the future, there will be an experimental knitting talk series from the Unstable Design Lab. Thank you. That's all that I have today.
That's amazing. Thank you so much. We can do claps in the chat, or you're welcome to unmute and clap. But it's perfectly timed because Stephen and I spent the weekend with some people doing flatbed machine knitting. And then both were like, oh, it's so fast. Like, what? So yes to knitting. I don't know if I'd have the best expertise for that, but it would be such a cool idea. I took so many screen grabs that I think I have your entire talk screen grabs. Yes, yes.
I can just send it to you.
I know.
There are solutions here.
I know. It was maybe more of like a, yeah, just like a way of, you know, when you like take notes with, you put it in your body, like, okay, I'm gonna screen grab it. But one of the things I really loved, in terms of the overall message of your talk, is this idea of exploration for exploration's sake. And I'm curious if you can reflect on that through both your experience in industry and also just in your personal practice. Does it seem more accessible in one place than another? Or do you feel like you have to kind of argue for that at certain times?
I think that exploration for exploration's sake has been possible in both industry as well as in my personal practice, and I think to varying degrees. Um, I think one thing that doing exploration in industry actually confers is the ability and access to resources that you might not have as an individual, and that might be physical equipment, it might be yarns, it might be doing work at scale to make certain discoveries that can only happen through brute force. And so I think that that is a really interesting avenue of exploration. And I appreciate having that because I think that sort of like quality of working at scale is something that is hard to do as an individual artist. But that being said, I think that there's a way in which your mind can wander as an artist where you aren't constrained by time. So whereas you might be constrained by resources and the number of phones that you can buy, or like the physical labor and your physical time and weaving anything on a floor loom, while you're constrained in that way, you're sort of less constrained in terms of time and expectation. And so I think that that can be really liberating too. And so I think that there's just sort of areas in which both can move you forward and areas in which both can hold you back.
Yeah, that's really nicely put. I had never thought about it that way, but it makes a lot of sense that you're sort of trading one for the other. I definitely want to give some space for our audience to ask questions. So if you do have questions within the audience, feel free to just drop them in the chat. If not, I'll just keep asking questions because I have a lot. Which my next one is just about like this talk, and the way you describe things is very systematic, right? Like there's a matrix and there's trade-offs, and like for every concept, I feel like I can almost draw a little graph. I'm just wondering if you could reflect on the role of like systems in your process as both a metaphor and a like practical way of understanding.
Yeah, it's funny that you bring up the word systems because I feel like systems really is the through line of all of the work that I make. And I think from a conceptual standpoint, I think that textiles is a system. The formation of textiles, the way that weave structures are kind of like this form of binary code, this input-output relationship. But I also think that textiles as a form of computation is a system. There are digital systems, and I think a lot about sort of like our human system, society as a system, language as a system, where there are these like relationships that are symbolic that attach to ideas. And so I like the idea of systems describing the way that we behave and the way that we exist in the world. And the reason why, and that's not to sort of reduce the complexity of that. Like I think the world as an ecosystem is amazingly and infinitely complex. But I think that it's really helpful for me in terms of both my process and my conceptual framework to think about what are the things that are going into the system and what is the outcome of that. And therefore, like, how do you make a change? So in the work that I make, how do I affect a change or achieve a certain outcome? But as like a person existing in the world, like, what do I do to input myself into the system of a society or the system of the environment to make a change? And I think that that really helps sort of understand like what I can do to have the most impact, right? Like maybe something like the number of layers in a textile is going to have more impact than the yarn twist. And in the same way, maybe me recycling a water bottle versus me like getting out into the streets, like weighing things like that, I think also help me understand like where are the areas in which I should get angry and where are the areas that I should be spending most of my time.
Yeah.
So I don't know. I think that framework is helpful for me to exist in the world, but also really helpful for the work.
Yeah, it's nice too, because this is like, it's not a perfect model, but it's a useful model and it can always be kind of reconstructed and reimagined in different ways. Um,
Mhm.
I do see a question from the audience. I'm going to turn it, Stephen, do you want to be our audience moderator?
Oh yeah, I'll be the person with the microphone out in the audience. Alice Busso asks, what role does computation play in your practice? I suspect quite a bit, but I'll let you answer that question. I'm excited to hear.
Yeah, I mean, it's interesting. Like, I think that computation is just like threaded throughout all of the work. I rarely find myself not making. I pretty much am always making with a form of like software as mediation, and that's in a lot of the image processing work, a lot of the weave structures, all of that is happening through the systems of software, which I'm just incredibly grateful for because I think it expedites, it like outsources my mental capacity to focus on things like concept and things like the visual aesthetic and things like exploring materiality that can't be described by a computer, right? But the things like where the yarn goes or which heddle gets lifted or where the color gets allocated in terms of best rendering an image. Like I think that I rely a lot on computation and these processes to achieve those ends. And then I also want the work to speak to reveal that computation is a part of it. And so, for example, those pieces with the gradients, there was an aspect of sort of like algorithm or computation in that where all of those gradients are calculated by an algorithm that uses like a graphing function. So if you have like an X and a Y axis, the rate of change can be described as being linear if that like graphing function is straight, but it can also be sort of like a parabolic function or any sort of graphing function can describe that rate of change. And I think that even if you don't know that about the work, the way that you perceive the work can detect that there is something that is like mediated by technology in it. So I think that it sort of like plays at different levels, but it's very much a part of the work.
Yeah, I love those. I love just the precision of those gradient pieces. There's like gradients, right? We see gradients, it's a common aesthetic right now, but I think you took it to like elevated it with that piece and made it so like intentional and controlled in the way that a gradient has like a fractal quality, but you sort of
Mm-hmm.
made it that weaving really has such intentionality to every level of the gradient. I'm such a fan of it. We have another question from one of the students in Laura's class. Nikita is asking a question about intentionality in your work, and maybe this is a question about intuitive weaving, perhaps. But if you see the question there, basically they're asking, do you feel that experimentation can be intentional slash calculated? And I think I see that in work, but they say, I often realize that I could do something better halfway through implementation. I also sometimes feel I get bound to a concept when it's that structured. How do you feel about this idea of experimentation versus, I guess, kind of execution when something is on the warp? Do you kind of change gears halfway through sometimes when you have some yardage coming out?
All of the time. I do think that there's like a point at which it's intentional and calculated, but that's why I think that that sort of like induction deduction framework, that sort of like bouncing back and forth. That's why I think it's so helpful, is because like the first starting point is like you think that you know the space really well. You think, okay, like this is what I'm going to do. This is how I'm going to execute it, and I know that these three things matter. Like, oh, I know that like the material type, or like for example, in the project that the experimental weaving residency did with the ECG, like I know that like there's going to be some kind of metallic yarn. I know there's going to be some kind of weave structure. I know that it's going to be like using Jacquard or tapestry to like localize this patch. So that's your starting point, and then you execute on it. But then you find out like, oh, actually, like there are a million other factors that are important here. Like, oh, maybe it's too scratchy. So like maybe this direction of taking like something that has so much metal in it is something that we need to step back from. Or maybe we find that the conductivity isn't high enough, so we actually need to move more in the direction of something that's closer to like metal wire. I think that like the sort of like rigidity that is conferred by this idea of like being intentional and calculated is sort of relieved in that way, because then you realize like, oh, actually, like I can just apply this framework, but incorporate what I know now from what I've learned, and rebuild my model and try this experiment again. And I think that that like allows you to be more generous with yourself too, because then you don't have to like full commit to executing on something, especially when you know more after trying something than you did when you first started.
Thank you so much. That's such a relief. I mean, I love hearing that response. That you're having the same struggles that I think a lot of us have when we
Gotta
start
be,
something.
you gotta be gentle with yourself.
I know, right? Exactly. So I have a question for you, Jessy. I would love if you would take, I know you are, congratulations, you are a Fulbright scholar to Taiwan currently, and that's what has brought you there. Wow, that's amazing. I'm going to brag for you how impressive and amazing that is. That's quite a feat. Will you talk to us a little bit about your project there and what you're working on while you're in Taiwan?
So my project is kind of twofold. The first aspect of it is I think just sort of like the textile nerd that I am, I'm interested in sort of like the formal qualities of the knot. I think there's sort of like a lot of these like mathematical principles that are built into it. I think that the way that it comes together is like really beautiful. A lot of it in the formation of the knot comes down to like this symmetry as you pull the cords to apply the tension in the formation of the knot as a form. But I think that there is sort of this sculptural aspect to it too, which I think is really beautiful. And I think the knot is something that is pretty unique compared to other textile techniques because it is so like discretized. It is sort of like sculptural unto itself. And I think that there isn't really like an industrialized process that can currently make these knots, which I think makes it interesting too. So I think that there's just this sort of like interest in that regard. But then the other prong of my project that I'm interested in, and I'd be curious to get feedback from you all in the audience as well, is I think that like a lot of the fine arts are sort of grounded in like a visual modality where you go into a museum and you perceive things like with your eyes, or maybe there's like a soundscape that you can encounter. But I think that aesthetic experience can also happen through tactility. And I'm particularly interested, I'm working with my sister who is a researcher in signed and gestured languages and providing access to art to communities like the deafblind community that experience things like primarily through the modality of touch. So that's something that I'm really interested in as well. I think that that's something that is useful for that community in particular, but I think that as individuals, like perceiving the world through these other modalities can really like deepen our experience too. And it can sort of like heighten our sensitivity to the material world around us. So that's the other prong, is sort of this like non-visual modality of experiencing art.
Yeah, I think that's where it becomes a privilege to be more of an instructor, because it also is an interesting request to ask somebody entering a gallery. I think for some people they're coming in with this, but for others, like that they will have to do some labor, and I think to sort of understand tactility and embodiment, there's an ask about like, you need to struggle with this for a little bit and feel it and reimagine what you thought it was. So it's an interesting kind of like how to make it a challenge yet not a game, and how to present it in these different ways. But that is a nice thing about getting to teach a class on weaving for 15 weeks, is there's sufficient time to frustrate the students, all of whom have raised their hands when I asked how many wanted to throw the loom out the window at one point. but we've moved past that. It's getting better. But yeah, I don't know. Thoughts from the audience, maybe. The void, the Zoom void audience.
Yeah, this research is really exciting, Jessy. I'll just say I'm thrilled to see it happening, and I think that textiles is really a great place for this type of inquiry, right? Because I'm sure people will echo in our audience, if they've ever shown work in a fine arts environment, people are going to touch it, especially textiles, right? There's a authority that people take with touching it. So I'm really excited to see the research that comes out of this. Oh, we do have a couple questions coming in. Oh my gosh, we have so many good questions coming. One is that a great question from Dover. How do you manage to curb your frustration when you realize you've missed or made a mistake? I'm assuming you don't make mistakes, but possibly
That's not true. I think that I'm no different from other people in terms of curbing my frustration. I normally will like try to take a walk and like drink some water and have some distance because I think that there are some things that you just kind of have to let go of. And oftentimes if there's a mistake that's too difficult to resolve, I think that I find myself either questioning, like, is it just going to exist as part of the work, or should I remake the work? And I think that, like, just knowing that there's another day and that your hands are capable and that your mind is capable and that you've like learned something and making it the first time, I think is also like a little bit of a relief. But I don't know, we're all human. We all make mistakes and we all get frustrated by them.
Yeah, absolutely. Thank you for that.
I don't know if that's satisfying.
Get so excited. So a question from Rebecca Smith, complimenting you on your knots and the beautiful slides that you made there. Are you inspired by anyone in the field in particular with your knot work? Just wondering what other people you know who are working in this vein of practice with knots.
Interesting. I like this idea of sort of like not as like a sculptural object, and I think Ruth Asala is someone who does that really well. I also think that it's like too easy for textiles to fall in sort of like this planar category where you're just making material, and I really like that there's sort of like not as like a sculptural form that sort of exists in three-dimensional space, and you can like observe it across like multiple angles. And so I think that there are a lot of artists who also work with knots in sort of like a sculptural context. And I'm probably not going to get their names right, but there is a woman called Cecile Vicuña, and then another Latin American artist who I can't remember the name of, but if there's like a listserv or something, I can pull those up at a later point. I think that it's really a great sort of platform for dealing with materiality and dealing with spatiality.
Thank you so much. I have a couple technical questions for you as well. Question about your gradient radiance, your radiant, gradients. Gradient. Question is what, two questions, one part, are you using a specific program to create this gradient? And then part two of that is, are you doing custom dyes for those warps, or are you using an industrial source for those warps, for that gradient piece?
All of the yarns are just yarns that I've gotten. I'm just very much in the habit of like recycling yarns, so people like will use me as like a trash can for yarns that they don't want, and then I turn them into gradients because I have so many random colors. And then as far as program is concerned, like because these are all like these like graphing function gradients, it's just really simple as well. It's all in Excel. It's just like formulas, and then Excel spits out some numbers, and then I count the picks. So it's very, very basic. It's nothing. So there's no custom software for it or anything.
That's fantastic. I love that. We have a couple more kind of questions coming out here. A couple comments. I encourage you to check out great people saying great things about your presentation and how excited they are about you. But also a question of where the kind of framework or model your approach came from to this current body of work. Did that framework come to be from your senior thesis or from your master's thesis? Or was it created after learning from industry? Where did that influence come from? I know you're unique in this situation where you have worked inside of textile industry a little bit more than maybe some other folks. So I'm really curious about this question as well.
Yeah, I think that this idea of like system level thinking is something that I've thought about a lot, and that was something that probably came from school. But I think that working in industry really helped refine that. And I think the reason why is because I think that there are a lot of engineering tools that are used to sort of used for the function of analyzing, like analyzing data. But I think it's rarely used in industry to apply more broadly to like a conceptual space or to capture the breadth of something beyond just solving a highly specific problem. But what has really helped me in being in that space is applying some of those principles, some of those softwares in that case, like the statistical analysis software, in thinking about how does experimentation actually work? What is the mechanism at play, like in your mind and in your process, that is helping you make learnings and arriving at the next stage? So I actually had some of these like backup slides of examples of experimentation where I've like made mistakes and then used an experiment, this like induction deduction, this factors and responses experimental process to solve them. And you end up with some like really wacky jerry-rigged solutions for like the way that you're like tying up different parts on your loom, or the way that you're like connecting warp yarns that like solve the problem. But yeah, I just think that like this experimental process, and knowing that like through iteration, you're probably going to arrive at something that works. It's something that both industry and my way of thinking in school, I think, have really helped hone. I've kind of just like honed that over the years.
Thank you so much. And thanks for your insights on that, Jessy. I just appreciate it so much, and your willingness to share that with us. Another question from Nikita this morning, which I think, Nikita, is a question that I think a lot of folks maybe have for you, and they're asking specifically about your work with Apple, and they want to know these kind of industry companies, are they looking for people with textile experience or software experience? And, you know, based on your roles, you know, there's a lot of design students in this class, and they're curious about that path to gainful employment and other said things with their newly found textile skills. So where would you say those kind of companies where you were developing for Apple, I believe, like, was it a software, a textile that would go on the headphones of their Bose headphones or the Beats headphones? Is that correct?
Yeah, they're actually just the Apple headphones, but
Just the Apple headphones, yeah.
yeah, but it is. I worked on the ear cup textile as well as the canopy and the driver textile. Those are all knitted fabrics, and I think that what is like really heartening in terms of gainful employment is the degree that I got was specifically a textiles design degree, and I didn't have expertise in software, computer science, hardware engineering, material science. None of that was something that I knew going into the job, but they were things that I was open and curious to learn. And I think that it was heartening, because I think that having a textiles background, being the only thing that you need, is like, it's a little bit surprising, but it's definitely possible. And I think what enables you to be a compelling person to work in that space is really just like this intense drive towards understanding structure. And so like really understanding like what's the interaction between the warp and the weft yarn when you go from a satin to a twill, right? Like a twill, because it has this diagonal tracking, there's actually more friction in that way. So it packs actually a little bit less than the satin, even though the float length might be the same. And so those are the things that you kind of just like observe when you're working with a loom or you're working with the knitting machine. And I think just like driving towards that sort of like really fundamentally understanding structure is something that these companies look for, and everything else you can learn, like all the software stuff, all of the things that go into the day-to-day of like executing on the job, you can learn when you're there.
You heard it from us, folks. Everybody should go to the textile school. No CS, no CS, just textile school, everybody.
CS isn't so bad. Come on.
Laura, did you have any last comments for Jessy? I know it's nearly midnight where she is,
Yeah.
and so we'd love to not go too late for her tonight. Thank you, Jessy, so much for making time for us today.
Yeah,
no problem. I took a nap, so I'm good.
Okay. Well, perfect. Well, I will just say thank you so much. I really appreciate the structure and the clarity that you brought even to your presentation and the question and answer. And I think my intuition is that the audience has gained a lot from this, and I'm certainly benefiting from having that, like, God, I really want to go play on a loom right now. You know, so that's like maybe the highest compliment for weaving is like, and maybe actually I have my knitting here too. I should have been knitting through it. I'm not super great at it. Anyway, I just wanted to say thank you, and also let the audience know that our next speaker in the series will be Allison Ainsworth, who's also coming from a perspective of industry, developing textiles for upholstery and such, aside from her more experimental and artistic practice. So we hope to see you again next week. And thank you so much, Jessy. And if you wouldn't mind sticking around for the class for just a minute, we'll just say goodbye to the rest of the audience. So goodbye, rest of the audience.